So last class, we had just seen how to create a database, right? So we defined what a database is. Then we created a database. And within that database, we have created a table, right? So we created a table, we put some records into it. So we have seen some commands. We used certain commands, right? So like create table, right? And then insert command. Then we saw select, right? So these are all, so this is what you call a command, right? So this is the name of the command. Insert is a command, right? So select is a command. And to use this create, you need to give some additional information, right? So today what we will do, we will see what are these commands, under what categories they come, right? So they all have their own specific functionality. And then we will go through the commands one by one, right? I hope you're fine with what we did till yesterday. Any questions in that?
No, ma'am.
Okay, fine. So let us first write down the commands that we are going to learn, right? So when you talk about SQL commands, so they can be put under different categories, right? Let me try and draw a straight line. Okay, that is straight enough. So we are going to look at first what is called DDL commands. DDL stands for data definition. And here we deal with the structure, right? Or let's say this deals with what are called database objects. We will see what they are. Objects. Then the second set is called DML, which stands for data manipulation. Here we deal with the data, or rather we write data. Write data. Then we have the DQL option. So this stands for data query language. Here we read data. Then we have something called DCL, or data control. So this deals with permissions. And finally, we have something called transaction control, or TCL. Here we deal with commit, rollback, and all that, right? So the commands that come under this category, DDL, are the create command that we just saw, right, for creating a table. Then you have the alter table command, drop, rename, and truncate, right? So these 5 commands, you can remember them as Dr. Cat commands, right? So this is for truncate, alter, create, drop, and rename, right? So these 5 deal with the database objects. We'll see what database objects are, right? Then DML commands, here you have insert, update, and delete. And then under DQL, we have only one command, select. But as a data analyst, 95%, this is what you will be using, right? Under DCL, we have what is called grant and revoke. And finally, under TCL, you have commit, rollback, and save point. Okay, so this is the basic command set, or this is what you call the basic SQL language, right? So if you remember yesterday when we talked about different RDBMS and different databases, we said if you learn SQL, right, you can interact with any of the DBMS, any of the RDBMS databases, right, like Oracle, PostgreSQL, all those. So this set of commands, right? So these are the core set of commands which you can use with any database. There will be other commands which are not supported. Like yesterday we did, if you remember, describe table.
Yeah.
Yeah, so those are like peripheral commands. So they may not work on other databases. But this set of commands that you see, this is the one that you can use on any database. And one more thing, when we write the syntax for these, right? So when we write the format of this, we will follow the format that can be used on all the databases. So if you look at specific MySQL books or sites, you might see slightly different variation of the commands also, but we will focus on the format which you can use on all the tables, all the databases, right? So we have seen a few of these, right? So we saw create, we saw insert, and we saw select. But we will go through them one by one, right? And what we mean by DDL, what we mean by DML and all that. So DDL commands deal with database objects, right? So when you say database objects, anything that you create on a database, right? So the basic object is the table, right? Not the data, right? But just the table. So when we say table, the structure of the table, right? So this is what your DDL talks about. Table is an object. So how to create the table, how to alter the table, how to give name to the table, all those will come under the DDL category, right? So later on, we will learn about other objects also, like sequence objects. We will learn about something called a view. We will learn about indexes. We will learn all the programming constructs like stored procedures, functions, triggers, right? So these are all the database objects that we are going to learn. And to create these objects, to make changes to these objects, to remove these objects, we need DDL command, right? DDL set of commands. So they follow a certain pattern, right? So that you can keep the syntax in mind. So if you want to create a table, right, you will say create table. And then you will give all the details that are needed to create a table. If you want to create a view, you will say create view. And this will be followed by the name of the table, right? And then the details to create the table. So if you want to create a view, you will say create view, name of the view, right? So any name that you want to give, and the details to create the view. If you want to create an index, you will say create index, name of the index, right? So don't worry what these things are. I'm just telling you the format, right? If you want to create a procedure, you will say create procedure, name of the procedure, right? So it follows the same pattern, but what details you need to specify to create that object will be different, right? So to create a function, create function, name of the function, and the details for the function. To create a trigger, we'll say create trigger, name of the trigger, and the details for creating it, right? Sequence is an exception in MySQL. If you are using Oracle, you can create sequence by saying create sequence, name of the sequence, right? But MySQL doesn't support it as of now. Here we use an option called auto increment to create the sequence. But otherwise, other databases all use the same format. Create sequence, name of the sequence, and there is a lot of options there, right? This is not yet fully developed in MySQL. So we at the moment, we can use the auto increment option to create a sequence. But otherwise, the create, so this is the name of the command, right? So the command that we are using is the create command. And this is used to create database objects. And what are database objects? These are all the objects that you can create inside a database, right? Everything except the data. So here we talk about the structure, right? So when you say create table, we are talking about the structure of the table, right? So one example that we take is you can think of the table as a house and anything to do with the building the house, right? So that doesn't look like house. Okay. So anything to do with building the house is what your DDL command is all about, right? The DML and DQL commands are the ones that deal with the data. So you can think of those as dealing with people inside the house, right? So DDL deals with the structure and DML is the one that DML and DQL are the ones that deal with actual data, records, right? So data related commands. This deals with the structure. Okay. So this is, if you remember, yesterday we inserted a couple of records, right, for George and Mary. So that is where we are talking about data, right? And when we said select star from table, we were able to see records belonging to George and Mary. So these are the ones that deal with the data, right? So let's go through, we will talk about these later, right? This let us focus on now. So we'll start with the create command. So yesterday we wrote the syntax to create a table, right? So what is the syntax? If you want to create a table called students, right? Any table, first you have to decide the name of the table. What are you going to call it? And then what are the attributes about the table this entity called students you want to store? And what name are you going to give it, right? So you can call it SID, STDID, student ID. But let's say we call it SID, S name, age, and the course. This is what we had decided. And the next thing we have to decide is what is the data type, right? Integer, character of 20, integer, char of 20. So once you decide this, we are ready to create the table. And to create the table, we have to say create table, name of the table, then column name, data type, then the next column name, a comma here, right? So, and then data type. So this is how we create the table. So the main thing here is, of course, these things we have to decide, right? So what column, what is the name of the column, what are the information we want to store? But then to create this, we need to be able to select the right data type, right? So that means we need to understand what all data types are supported in MySQL, right? You said Python is not done, no? Is it done for you?
No.
Okay. Okay, a data type, basically, what are the kinds of data that your system can handle, right? So if you know those, then you can decide what is the data type, and then you can go ahead and create your tables. So first, let us understand what are the data types that are supported by MySQL. So any language, right? So when you start learning Python also, you will see what are the types of data that Python will understand. So when it comes to MySQL, it can understand numbers, numeric data. It can understand characters, character data. It can understand date, right? It can understand binary objects. When you say binary objects, things like your photographs, MP3, right? So things that you cannot read on your own. If you try to open it, you will see some junk characters. So images, right? So videos. So those things come under the binary category. But for us as data analysts, these are the data that you will be constantly working with. So when you say numeric, there are two types. You can have whole numbers and you can have fractions, right? Whole numbers are the integer category. They are called integers because they are called integral numbers. Integral numbers are full numbers, whole numbers, no fractions, right? So integers, and there are different flavors of integers. Then coming to fractions, you have something called floating point, float data type. You have something called double data type. And then you have something called decimal data type, right? So let's look at these data and see what they are. So coming to numeric type of data, you can see these are the different versions of numeric data, right? So you can see, like we said, there are different flavors of integers here. All of these deal with integers. That is, all of these deal with whole numbers. So if you see what is the difference between these two, the difference here is what is the maximum value that you can put into a column, right? So if you declare a column to be of type tiny int, the maximum number you can put into it is 255. Remember, it is not the number of rows, but what is the maximum value that you can put, right? What number can you put inside it? So if you want to store a number like 320, then obviously tiny int is not enough, right? So you have to go for the next biggest value of integer, which is small int. So if you see small int, you can store numbers up to this much, right? If you want to store a bigger number, you have to go for medium int. If you want anything bigger, you can go for int. And then if you want something even bigger, you can go for big int, right? Just a moment. So why do we have this restriction, right? So why is it that if you declare something as small int, you can put only this much, right? So the reason is it depends on how much memory it takes up. So tiny int takes 1 byte of memory, right? What is a byte? What is 1 byte?
8 bits.
8 bits. 8 bits, right? So if let's say you have 4 bits of memory available, what is the maximum number that you can put into 4 bits? You have 0, 0, 0, 0, right? Or you can put 0, 0, 0, 1. So like this, if you have 4 bits of memory available, the maximum value that you can put into it is 1, 1, 1, 1. Right? So this is the minimum value. This is the maximum value. How do you convert from binary to decimal? Do you know this conversion? Okay, so if you have 4 ones, right? So the corresponding equivalent in decimal is 2 power 4 minus 1, right? So that is 15. Have you done decimal to binary, binary to decimal conversion? From long ago, you would have done it, right?
Yes, yes.
So you will take 2 power 0, 2 power 1, 2 power 2, 2 power 3, right? So if you have 4 bits, the maximum value you can store is 15, which is 2 power 4 minus 1. So if you have 1 byte of data, that is 8 bits, then the maximum you can put into it is 1, 1, 1, 1, 1, 1, 1, 1, right? So the equivalent of this is 2 power 8 minus 1. So that is 256 minus 1 or 255. Beyond this, if you want to put a bigger number, you need additional bits, right? So that is why we have this restriction. If you have declared a column to be of tiny int, it takes up only 1 byte of memory. So within 1 byte, the maximum number you can store is 255, right? Small int takes 2 bytes. Medium int takes 3 bytes. Int takes 4 bytes. And big int take 8 bytes in memory, right? So that is why we have this distinction. So so it depends on what kind of value you want to put into it, right? So for example, we said we are creating a column called age, and we have declared this as integer. But do we need an integer here? Are we going to store numbers as big as this? Right? So if you declare that column to be 4 bytes, then we are wasting space, right? So instead, I could have declared it to be of type tiny int, because definitely I'm not going to put a number more than 255 into it, right? So instead of wasting 4 bytes for every row, I can declare it to be tiny int, right? Because I know that I'm not going to store anything more than probably 100 into this. Okay. So depending upon what is it that you expect to store, what is the maximum value or what is the range of values you expect to store in that column, right? You can declare that you can choose your data type appropriately. So that is why we have so many versions of integer, right? So we will see shortly how much space we end up wasting, right? If you don't choose the right data type. But for the moment, a tiny int takes up 1 byte. So that means the maximum you can store into it is 255. So you can store numbers like 25, 47, right? So 64, 100. All this whole numbers can be stored in integers. What if you want to store plus 25, minus 47, minus 64? So if you want to store the sign also, then the maximum value that you can store is from minus 128 to plus 127, right? Why is there a limitation like this? The reason is, if you want to store the sign also, what will happen is the first digit will be used to store the sign, right? 0 means negative and 1 means positive number. So if I use 1 bit for sign, then I have only 7 bits to store the number. So if I have only 7 bits, the maximum number I can store is 2 power 7 minus 1, right? So in this case, it is 127, right? So if 1 bit goes for the sign, only the remaining is available. So what is the connection between 2 power 8 and 2 power 7? 2 power 8 divided by 2 is 2 power 7, right? So without sign, I can store 2 power 8. With sign, I can only store 2 power 8 divided by 2. So that is why you see exactly half of what you can store, right? So if you need the sign also, the magnitude of numbers you can store is exactly half of this. So from minus 128 to plus 127 is what you can store if you have 1 byte of data and you want to store the sign also, right? So this is true for every size. So if you have 16 bits, the maximum value you can store is 2 power 16. If you take 1 bit out for sign, you have only 15, right? So that means you can store only 2 power 15 as the maximum number. So 2 power 15 is 2 power 16 divided by 2, right? So exactly half the magnitude is what you can store if you want the sign as well. So here you can see, if you want it to be signed, then you can store from minus 128 to plus 127. Here, for a small int, if you want the sign, then only half of the value you can store, but you can store from minus this to plus this. Here also, this is exactly half. This is exactly half, right? So this is also exactly half. So if you want signed values, the magnitude that you can store will become half of that, right? But you can have a sign also, right? So these are the integer types of data, integral data types. So depending upon what we expect in that column, right, you can choose your data types appropriately. Don't end up putting integer everywhere if you don't plan to put this much value, right? So things like marks, for example, age. So all those, if you know it is going to be within this particular range, no need to have a bigger data type, right? So this is it about your integer data types, integral data types. Coming to floating, these three numbers are used to store fractions, right? So depending upon how you expect the values to be, let's say you plan to put values like 12.35, 43.67, right? So 17.35 and so on, right? So what we are saying is we will not exceed 99.99. So if this is how you expect your data to be, then you can declare this as float of this part is what you call the precision, right? So totally there are 4 digits, out of which 2 are the decimal part. So you can declare a column of type float of 4, 2. What if you have to store numbers like 1.347, 2.624, right? So 3.176. So we won't store anything more than 9.999. How will I declare this?
Four,
3. 4, 3, right? So totally we expect 4 digits, 3 of which are the precision. So depending upon the type or the magnitude of values, you will declare your floating point according to this. So if you are choosing float, then the decimal part can go up to 24 places, right? So that means I can store a number like 2.27345687124. Like this, I can keep going up to 24 decimal places, right? If you have a floating point data type. The double data type is called double because this stands for double precision, right? So this is double the precision of this. So here you can go up to 24 places. If you declare it as double, you can go up to 53 decimal places, right? If you are doing highly scientific calculations and all, you can go for double precision, but most of the cases we need only floating point. We are not going to use more than 24 decimal places in regular usage, right? So float and double are what you use for representing fractions. Here you see there is something called decimal, right? Decimal is also for storing fractions, but the thing is decimal is what you should use if you want to store currency data. So, what am I writing? Decimal, right? So decimal is what you should use if you want to store currency or money related data. So why we need this is because float and double won't be able to. Okay. How is data stored into memory? Whenever you are storing a number, right? So let us say you want to store a number called, let's say 7 or 6, right? So you have to store a number 6 in memory. So this is converted into binary, right? And then the binary version is what is stored into the computer. So what happens with the binary is, if you have whole numbers, you can convert from decimal to binary and binary back to decimal without any problems. But when you have fractions, right? So if you have a number like 6.34, this can be converted into binary, but sometimes this cannot be exactly converted, right? For example, if you see 10 by 3, for example, generally any fraction. What is 10 by 3?
3.333.
3.333, it will never stop, right? So there is no direct conversion. So at some point, your computer will truncate this and store it in memory. So when you get it back, you won't get 10, but you will end up getting 9.999, right? So there is some loss in data. So that is true when you convert from binary to decimal and decimal to binary in the case of fractions, right? So when you convert it into binary, it will not stop, right? So this might go on like this. So at some point it will truncate it, right? So that might lead to some loss of data. Normally, this is not a big deal, but when you're dealing with money, right, and when you have to add up long columns of numbers, this could become it could be as small as $2 or $3, right? Totally, if you see the loss. But then it is a big deal when you're dealing with financial data, if it is not tallying. So there we go for decimal, right? So which will take care of this, it will make sure that this data loss doesn't happen. So whenever you have any column like salary, stock price, any place where you're dealing with currency, go for decimal rather than float or binary, right? So, so these are the 3 floating point data types. If you want fractions, right, so you go for either float, mostly float. This is enough for most cases. Double if you want very high precision numbers, and decimal if you want to go for currency related data. Okay, so these are the numeric data types. Integer and different flavors of integer. Then for fractions, we have floating point, double, and decimal, right? Coming to character, there are different data types of for characters. You have char, you have varchar, you have tiny text, text, medium text, long text, right? So char and varchar are used. Here you specify a size here, right? So this means we are saying we are going to put character data, but we will not exceed whatever size is mentioned here. So the maximum you can put here is 255. Okay. So if you declare a column of type character, right? So here we have declared student name as character of 20, right? So if you declare a particular column of type character of 20, then it doesn't matter, right? So let's say you have the student name and age. This you have declared as character of 20. Age we have declared as integer, right? So if I want to store a record inside this, let's say I'm inserting a record called Joe and age is 32. So in order to store this, right, so what SQL will do is it will reserve 20 characters for student name, right? For the student name, it will reserve 20 character space. And for age, how much space does integer take? Integer take 4 bytes of data, right? Age, for age, it will reserve 4 bytes. But what is the value of age? Age is 32, right? So 32 can be fit in 1 byte only. Up to 255, you can fit it into 1 byte only, right? So 32 can be fit in one thing. And for character, it will reserve 20 characters. But how many characters are we actually using?
2.
We are using only 2 characters. So for one record, how much space did we waste? Here we have wasted 18 bytes. Let us assume one character takes 1 byte. 18 bytes is wasted here. 3 bytes are wasted here, right? So totally 21 bytes we have wasted for one record. If you think of only the age column, right? If there are 1 million records, how much space have you wasted for the age column itself? Three bytes for one record, right? So 3 million records are there. So 3 million bytes we are wasting, right? Because we chose the wrong data type, we end up wasting 3 million bytes of data only for the age column. How about the character column? We don't know, right? So some of them might be, the next name might be John. This will take up 3 spaces. The other might be Jonathan or something, right? So depending upon the size, it will take up that much space. That many characters will be occupied. But irrespective of what is the value you are actually storing, MySQL will always reserve 20 bytes of space for student name. So this would lead to a lot of data wastage, memory wastage. Instead of this, right? So let us say we have declared the column as student name. We declare this as varchar of 20, right? And age, we declare it as tiny int. Now, what happens at the backend? Your MySQL will use up only what you enter here, right? If you are entering Joe, if you are entering Joe and 32, right? How much space will this take? This will only take 2 character space for Joe, 2 characters for Joe, and 1 byte for age, right? So this will take up only this much space and memory. Can you see the difference in amount of memory that is saved?
Yes.
If you are storing John, then varchar will take up 3 bytes, right? So whatever it needs, only that much it will take. But here also you have the limitation that you cannot cross 20 if you declare it as 20, right? So John, but the thing is here we don't have to worry. We can safely say varchar of, 255, right? Because irrespective of what you declare here, it will only take up as much as it needs. So if you go for varchar, right, it is more memory efficient. So why do we need char? Why not go for varchar only? So the reason is varchar is memory efficient, but this is a little slow. When you want to retrieve data based on a varchar column, the retrieval will be slower, right? When it comes to char, it is fast, right? So data retrieval is fast, but it wastes memory. So it is up to us to choose the right value, right? So when can we go for char? In what kind of columns can we use char data type? And when can we go for varchar data type? What do you think? When can we use char? What is the problem? Sorry?
For fixed number of characters.
Fixed number of characters in the sense? You are right, right? So the problem with character is we think that if you declare 20 spaces, if you really are going to use 20 space, then fine, right? But if you declare 20 and sometimes you will use only 2 or 3, that is where the problem with char comes. So if you know that there is a column which will always take up so much space, right? Things like PAN number, right? Even if you have 1 billion records, right? So our 1.3 billion records, everybody's PAN number is going to be 10 characters long. So I can safely declare it as character of 10, right? Because there is not going to be any data memory wastage. All 10 spaces will be used up by all the records, right? So things like PAN number, Aadhaar number, vehicle number, right? Vehicle, or if you have probably your bank account, right? So let's say everybody in the bank has a 15-digit account number, right? So in cases like that, where you know that every record will definitely use this much space, you can go for care, right? So because you will see that whenever data is retrieved, it is retrieved based on something like this, right? So they'll ask for your PAN number or Aadhaar card details to retrieve data, right? So data retrieval will be fast and we are not wasting space also. So in cases like that, right, so you can go for care type. In cases where we don't know, right, so the things like name, for example, some people will have small names, some will have very big names, right? So here we don't know how much space we need. So in cases like this, you can go for varchar. And you will see people never retrieve data based on your name, right? So they will ask for your PAN number or account number. Based on that, only data retrieval will be done. So this will be fast. And name, we don't have an option, right? So some people will have, everybody will not have the same number of characters. So in cases like that, name, then maybe address, right? So things like this, which will be different for different people, there we will go for varchar, right? How about phone numbers? Cell number. What data type would you use?
Char.
Char.
Why care? Why not integers?
There will be no addition or subtraction kind of thing.
Yeah, we are not going to treat the phone number as a number, right? We are not going to treat it as numeric value. So you can declare this to be character of type, right? So depending upon your requirement, right, you will either choose char or varchar, which flavor of integer is right for you, which flavor of floating point is right for you, right? So depending upon that, you will choose your data type. If you want to store bigger chunks of data, right? So like some description, product description, articles, books, right? So if you want to store larger chunk of data, you will go for text, medium text, or long text. So if you have a long text, then you can store up to 4 GB of data, right? Again, for our purpose, for data analysis, probably we don't go for large text analysis. Mostly it will be like varchar or care, and numeric data and date related data is what we will be learning, right? So this is for your numeric and character data, right? So here we have seen char, varchar. I think yesterday somebody was asking the difference between char and varchar, right? So
Yeah.
that is fine. Then different versions of text data depending upon how much data you actually want to store, right? Then one of the most commonly used data type or most frequently used data type is a date type of data. Here we can store date, we can store time, right? So date and time. So coming to date type of data, these are the different options of date, right? So you have date, date time, timestamp, time, and year. So when you are entering data, right? So you for date, you have to enter it in this order. It has to be year first, then the month, then the day, right? And the range of values that you can put inside date column is anything from 1st Jan 1000 till 31st December 9990. right? So this is the format where you have to enter data in this format only, and you have to enclose it in quotes. Anything other than numbers need to be enclosed within quotes, right? Date time, again, you have the date part plus the time related part, right? So there is a space here and then a time related part, right? So this is a date time type of data type. Timestamp looks exactly like your date time, except there are a couple of differences. One is the range of values, right? So you can only store values from 1/1/1970 till 19/1/2038. Beyond this, you cannot store values, right? So there is a restriction here. So if you want to store something from 1952, you cannot put it inside this, right? And the main difference here is this UTC. Here it is stored in UTC format, right? So what is UTC? Universal coordinated time or time coordinated. It used to be called GMT, right? What is GMT?
Greenwich Mean Time.
Yeah, Greenwich Meridian Time or something, right? So this is because we want to have some common reference point, because different countries have different times. So this will be taken as common, right? So the GMT or UTC will be the same from whichever country you are checking, right? So India is how much? Plus 5.5 hours ahead of GMT, right? So this is the London time. And India is plus 5:30. Some other country will be plus 9:30. Somebody will be behind this, right? But from whichever country you are checking, the UTC will be the same at a given point, right? So what is the time now? It is close to 11 o'clock. So the GMT would be 5:30 in the morning or something, right? So if you check what is the UTC now, what is the UTC now? UTC now is 5:30, I think. UTC. No. Yeah, it is close to 5:30 AM, right? So from whichever part of the world you check the UTC, it is always going to be 5:30 AM on 24th January, right? So this conversion happens when you when you use timestamp to store your data, right? So time gets converted into UTC and it is stored. But let's first create a table, right, with the date and date time. Then we will come back and talk about timestamp, right? So I usually create a table called patients, right, where we have the patient ID, the name of the patient. Then we will get his date of birth, right, and the time of admission to the hospital. So patient ID, we will make it as integer. Name, we will make it as varchar, right? DOB will be date, and time of admission, we will make it as date time, right? So we will create this table and we'll try to insert some records into it so that we know how to enter date and date time data, right? So let's do this. So like I mentioned yesterday, I don't like to use the workbench, right? So I will use the command line. You guys can continue using workbench if you like it. Whatever I'm typing, you can type there, right? So it doesn't matter what interface we are going to use. So I'm going to use this, right? What was the name of the database? We called
MODB.
DemoDB. Okay, use DemoDB. You also, the moment you open your workbench, please use the database, otherwise nothing will work. So MySQL. So now let us create Let me see what tables are there. Show tables. So till now we have only created a table called students, right? So now we will create a new table. Patients. Then we have patient ID, integer. Patient name, varchar of 30. Then date of birth of type date and time of admission, time stamp. Now let's make a date time, right? Date time. Right. So then let us put a couple of records, then I'll give you time, right? So then you can also create. So I will insert into patients, values, right? Patient ID 1, name is Tom, and let's say Tom, and date of birth again has to be given within quotes. Let's say this person was born in 1990, September 19, right? And the time of admission, let's say they got admitted yesterday. So that is 2023, Jan 23, right? Yesterday was 23. And time also we have to give. So give a space. Let's say morning 7:30, they got admitted, right? So 07:30:00. Close quotes, close bracket, right? So this will insert one record. Let's insert one more record, right? We will insert. Please go on mute, all of you. Okay. The second patient, let's say, is Pat or Patrick. Let's say he was born in 1987, July 14th, right? And then he got admitted last night at 7:30, right? So same date, 2023, 01/23, but night 7:30. So that means 19:30:00, close quotes, right? So now how do we see what we have inserted? We will say select star from patients, right? Can you create this table and put 2 records and then let me know? If you face any issues, let me know. If you get any error or something, that also you can say. Done. Let's do something. Let's take a break and come back. Right, it's 11:03. Let's come back at 11:10 or 11:11.
Okay, ma'am.
Yeah. Yeah, hi. Were you all able to create this and put records?
Yes, ma'am.
Fine then. So this is about your date time, right? Coming to timestamp, the format is exactly the same, right? But when you're creating this, you will declare this as timestamp. The difference is when it is getting stored in the backend, right? So whenever you store data into the backend, if you have declared it as timestamp, what happens is data gets stored in UTC format, right? So it doesn't matter from where in the world you are storing the data always gets stored in UTC, right? So let us say you have a distributed application or this patient database itself. Let's say this is located on the cloud somewhere, right? So it doesn't matter where it is. Let's say it is there in Sydney. Yeah, your database is located on the cloud. Somebody is getting an error. You need to show me the error. Okay, let us see. I think nothing has happened. Did you say use DemoDB? The first thing that you have to say is use DemoDB. Yeah, that is why. Do that and then execute these commands once again. It will get executed. Right. Otherwise, you will get the session. All right. So let's say we have the server at Sydney, and here we have created the patients table. Right. And let's say we are entering data from different parts of the world. Let's say you have a branch of it here in India. Right. So let's say you have a branch in Bangalore. So somebody is connecting through Workbench to the server, which is located in Sydney, right, from Bangalore. And somebody is connecting to this from Singapore, for example. They are connecting through their Workbench from Singapore. Right. So we want to put entries into the patient table. Right. So let's say one patient is getting admitted now, 11:15 p.m. a.m. from Bangalore, right? So patient 1 is getting admitted. Here, let's make it 11:30 so that calculation will be easy. So somebody is getting admitted at 11:30 a.m. right, from Bangalore. So the record will be inserted if you have date time, right? So if you have declared your column as date time, then what will get included, inserted is P1 got admitted at 11:30 a.m. Right. So this is what goes into the table. So if at the same time, if somebody is getting admitted from Singapore, right? So patient 2 is also getting admitted at the exact same time. But then the data that will go into it will be, I think, 2 p.m. for them. Right. So right now, I think it is 2 p.m. So the data will go into the database table as P2, 2 p.m. 2 p.m. Right. Although these two patients are getting admitted at the exact same time, whenever somebody says select star from patients from Bangalore, they will see that patient 1 got admitted at 11:30 and patient 2 got admitted at 2 p.m. Right. So similarly here also, if anybody says select star from patients, this is what they will see. Right. So 11:30 a.m. and 2 p.m., although they got admitted at the same time. Right. But if you have declared your time as timestamp, the time of admission is timestamp, then what will get stored in the backend is P1 got admitted at 11:30. What is the UTC? 6 p.m. 6 a.m. Right? 6 a.m. which is the UTC corresponding to 11:30 a.m. Similarly, because this person is getting admitted at the exact same time, P2 also got admitted at 6 a.m. UTC. Irrespective of from where they have got admitted, both of them got admitted at the same time, right? So what will go into the table is both got admitted at 6 a.m. UTC. So now when somebody says select star from patients from Bangalore, they will see that patient 1 got admitted at 11:30 a.m. and patient 2 also got admitted at 11:30 a.m. If somebody says select star from patients from Singapore, they will see that patient 1 got admitted at 2 p.m. and patient 2 also got admitted at 2 p.m. Right? So what is happening is, while storing, it gets converted into UTC. While retrieving, it is getting converted into the local time zone. Right? So this number gets converted into Indian Standard Time if you are querying from Bangalore. If you query from Singapore, this will be converted into Singapore time, and that is what will be displayed here. Right? So if you are working with multiple time zones and you want this kind of conversions to automatically happen, then you can go for timestamp type of data. If you are fine with this kind of data, then you can go for date type. Right? So the limitation here is only certain range of values are supported. You can't have it for all ranges, right? Here, this is supported for all ranges. Are we fine with the difference between date time and timestamp?
Yes.
Yeah. So basically, it gets stored in UTC format and it is displayed in local time zone, right? So this is your timestamp and date time. Then you have year, time, and all. Year is when you want to store only yearly data, like yearly profit or yearly GDP and all. Then month doesn't, date doesn't make sense, right? So in 2000, this is the profit, 2001, this is the GDP, 2002, this is the GDP and stuff like that. You don't need complete date, right? Only year is more than enough for us. So in that case, you will go for year as the data type. If you don't want to store full 2000, you want to store 0, 0, 0, 1, 0, 2, right? So 98, 99 and all. Then you can go for year of 2. Otherwise, you can declare this as year of 4. Time, again, there are certain applications where you don't need the date. Right, probably something like bus timings or train timings. So every day the arrival will be the same, right? So the departure will be the same. So arrival time is 11:30 00 and departure time is 11:35 something, right? So in this case, we don't need the date. Only time is more than enough. So you will declare this column as time, right? What is the maximum and minimum value here? What will be the maximum and minimum value that you can store in the time column? Are you there?
Minus 838. That one.
Yeah, I know. I'm asking you, what do you think should be the maximum and minimum time? This would be the maximum time that we need.
Yes.
0, 0, 0.
Minimum will be 0, 0, right? So why do we have minus 838 plus 838 and all? So the reason we have this range of values is because sometimes what you might want to do is you might want to store not the actual time, but probably the difference in times. right? So you might want to store the difference between, 1st Jan, 11:30 a.m. And there might be another date, which is 3rd Jan, let's say 9:30 a.m., right? You might want to store the difference in time between these two. So this will be somewhere close to 72 hours or something, right? So 72 hours, 34 minutes or something like that. So in order to allow you to store time differences, right? So difference in two different dates in terms of time, you are allowed to have extra values here. So you can store up to minus 838 to plus 838 hours. Right, so I can say the difference between 1st Jan and 3rd Jan is minus 72 hours, 34 minutes. So whenever you want to store time differences, right, so you might need values beyond 24. So, so that is why we have this extra range. But otherwise, normally the maximum value that you need is 23, 59, 59, and minimum value will be 00, right? So these are your date and time related data types. Date will have only the date part. Date time will have date plus time. Timestamp when you want to look time zone related support, right? So you store in UTC and retrieve in local time zone. Time when you want to store only the time, or if you want to store the differences in terms of hours, then you will go for time. Year when you want to store only the year part, right? So these are your date and time data types. So these three are the most commonly used data types for us. Then we have binary data, right? So like I said, if you want to store a photograph, let's say some passport size photograph, or you want to upload some PDF documents, you want to put some MP3, right, or some videos. So when you want to store these kind of data, you go for binary data. So binary large object or the blob data types, right? So blob stands for binary large object. Small passport size photographs and all, 255 bytes might be enough. Something bigger, you go for blob or medium blob, which will allow you to store this much data, right? Again, from a perspective of a data analyst, you are not going to analyze binary data, but for the sake of completion, right, it is good to know that there is a data type like this. You can't do direct insert of data, right? So you have to load it from some file. You have to load a picture from .png file into this column, right? So you can't say insert into table and give the name of an image or anything, right? So you have to follow a different way of inserting this data. So it's enough to know that there is a binary object support. You can store pictures, PDFs and all in the database. So if at all you have such a requirement, you go for the large object or the binary large objects, tiny blob, blob and medium blob, right? There are a couple of additional data types, right? So some specialized data types like spatial types. So spatial category is used to store geometric data. It allows you to store shapes, right? So things like points. When you say point, a point will be stored in the form of x, y, right? So the coordinates, rectangle, right? Square. So those kind of shapes can be stored inside spatial data types. Again, not for us, right? So not for data analysis. Points might be useful, right? Because if you're storing any geospatial data, like latitude, longitude and all, you might go for point data type, right? But other than that, normally we don't use the spatial data types. This is a specialized data type. And this is not the same in all the databases, right? So MySQL has these, Oracle will have slightly different data types. There is something called spatial type, right? And there is also, so these we will not focus on, right? So what we will look at is numbers, characters, right? Text to some extent, and date and time. These are the most commonly used data types. Okay. Finally, there is a special data type called the null data type. So null data type actually is not a data type, right? It will fit into any column. So null basically is used to represent unknown data. So whenever you are inserting records, right? So you may not have details about all the columns in the table, right? So if you create the students table, maybe you know the student ID, the name of the student, but let's say you don't know the age. So in that case, what you will do, you will put null into this, right? So let's say they are learning MySQL. There could be the second student, right? So student 2, you don't know the, let's say their name is Mary. She is 25 years old, but you don't know what course they are taking. So in both cases, what we do, we put null value. So you can see here, null is inserted into a column of type character. Here, null is inserted in a column of type integer, right? So it doesn't matter what data type it is, you can always put null into it. So null basically has, although we say it is a specific type of data, it doesn't have any data type, right? So the way you have to interpret null always is to think of it as unknown data. Don't think of it as 0. This is not 0. This is not blank space, right? So this is not a space. Null is null, right? It is unknown data. Don't think of it as 0, right? So whenever we are doing mathematical operations and all, whenever you have null values, right? So the result will always turn out to be null. So if you add something like this, right? So if you want to add two numbers, you can do something like this. You can say select 5 plus 6 as result. So you can see the result is 11, right? So you can multiply two numbers, 6 into 8 as result, right? So you can do mathematical calculations. What will happen if you add null? 6 plus null. What value do we get?
6.
So this is, you are saying 6 because you are thinking of null as 0.
Null. We'll get null.
How should we think of null? Null is, I don't know, it is some number, unknown number, right? If you add an unknown quantity to 6, the result will be unknown.
Yes, ma'am.
Right? Because we don't know what this is, the result will be unknown. So any arithmetic operation you do with null will always result in null. Right? So usually in interviews, there are many questions on nulls. So always think of null as unknown, and then you will be able to answer the questions. Right? So for example, let's say there is a column. Yeah, so you can see the result is null. So let's say I have a column, right, called student ID, and I'm saying only unique values can be put into it, right? I cannot have duplicate values. If I have 1 and I try to put 1 again, it will not allow, right? So let us say some way I have specified that this has to be unique. Will this allow null values or not? Can I put null into this? What do you think?
You know,
Why not?
null will be 1.
Yes.
Yes, you
And
can.
null is unique.
Yeah, you can put null into this, right? Can you put multiple nulls? If this is unique?
Yes.
Why?
Null, we don't know. It can be unique and can be anything.
Yeah. So the way we say that this is duplicate, this is repeated, is because we are comparing this to 1 and we are saying 1 is already there, right? So here we have an unknown number. Then we have another unknown number. Can I compare this unknown number to this unknown number? Right, so I can't say this unknown is the same as this unknown. This could be any value, this could be any value. Right, so any comparison with null will only result in null. So for example, if you say 2 is equal to 2, this is true. Right, so 2 is equal to 2 is true. 2 is equal to 3. Is it true or false?
False.
This is false. How about 2 is equal to null?
False.
Again, the answer is we don't know.
We don't know.
So null can be 2 also. Right, so whenever I compare 2 to null, the result is null. That is why always think of null as unknown. Is 2 equal to some unknown number? We don't know. The unknown could be 2 also, right? So the answer is null. So you cannot compare null with anything and say true or false. Only if you compare these two and say it is true, then we will know that it's a duplicate. Here I can't even compare these two. So how do I know whether it is duplicated or not? So if you declare a column as unique, nulls are allowed. And even if you put multiple null values, it will be allowed. Right? Always think of null as unknown. So if you want to do this comparison here, you can say select 2 is equal to 2 as result. You will get 1, right? So 1 means true. If you say 2 is equal to 3 as result, it will say 0. 0 stands for false. But if you say select 2 or 3 is equal to null, you won't get true or false, right? So you will get null only. It will say, I don't know if it is true or false. Right? So null is a very special data type. Always should be interpreted as unknown data. Right? So don't think of it as. There is one thing you can do with null. That is, you can use something called is null operator. Right? You can check 2 is null. This will say false. Right? So here we are not comparing 2 to some number. Instead, what we are checking is 2 unknown? Right? That is false because 2 is not unknown. We know 2 is 2. We are not comparing the values, right? So we are just checking is 2 unknown or not. So 2 is null will return false. True, 2 is not null will return true. Right? So is null and is not null are the two things that you can use with null operator, null data type. Other than this, any comparison, any addition, division, subtraction, anything you do with null values will always result in null values only. Okay. So this you have to keep in mind whenever you are selecting records. So if you say select 2 is null, right? So this will say this is false. If you say 2 is not null, then it will say true. Okay. So is null and is not null are the only two things you can use along with your null operation, null data type. Okay. So these are the data types that are supported in MySQL. Right.
What are the scenarios that we get null in database?
Whenever you don't know what value to put in a particular column, you will have null values inside it.
Okay.
Right. So there will be many cases where we don't have values for certain columns. So those will be null. Okay. So now we were talking about different commands, right? So we started with our create command, and there we started with data types. Now that we know all the data types, right? So we can create a table, right? For example, let us say we have the employee table. So in the employee table, we have employee ID, employee name, job, date of joining, salary, let's say photograph, resume, phone number, PAN card details, right? So let's say our table has these columns. Can you tell me what data types to use? Employee ID,
Integer,
Integer.
integer.
character, variable.
It can be character also, right? So it depends. If you're going to have employee IDs like E01, right? In that case, it will be character. Otherwise, it can be integer. Let's say character, right? So let us assume that in a company, everybody is given a employee ID of some 6 characters or something. Employee name,
Varchar.
this will be varchar. I can safely put it as 255, right? It will not waste space. Job, this will also be varchar.
Yes, Varchar.
Yeah, some 20 or 30 or something. Date of joining,
Date.
salary,
Decimal.
Decimal.
decimal, yes. Photograph,
Blob.
Binary or blob.
blob. Resume,
Text.
yeah, it could be text or it could be blob if you are uploading a PDF. Phone number,
Character.
character of 10. PAN number,
Character.
Character.
right? So now that we know how to select the data type, we can create our table. We'll say create table employee, employee ID care of 6, he named this, right? So we are ready to create a table. So other than this, there are other options that you can use when you're creating tables. Those options we will talk about when we talk about constraints. Let me just open that. Right. So this is the syntax for creating a table, right? So whenever you see the syntax in a book or a site, you will see this square bracket. So this square bracket should not be part of your command, right? So this is to tell you that whatever is inside this is optional. You may or may not enter this, right? So if you want, you can say create table if not exists students, right? So instead of saying create table students, you can say if not exists students and then the rest of the data, right? So what is the difference? If you say if not exists, so if you try to create a table that is already existing, you will get an error, right? So we have already created a table called students. So now if I try to create it once again, right, it will give me an error. So I will say create table students. Let's say I'm going to put only ID integer, just one column. So it says this table is already existing, right? So instead, if I say create table, if not exists. So this means if the table does not exist, go ahead and try to create it. If it is already there, then don't do anything, right? So that is the meaning of this if not exists. If not exists. How can we delete? Yeah, we will see. You will use a drop command. Okay, it's not delete. Deleting is for records. So you can say drop table students. Okay, so now if I say create table, if not exists students, then I won't get an error, right? It will just keep quiet, right? So it will not try to create a table once again. It will quietly exit without giving any errors, right? So the thing is, whenever you see something within square brackets, it means it is optional. But when you're actually writing the command, the square bracket should not be given. Anything within angular braces is something that you have to choose, right? So you have to choose the name of your table. You have to choose the data type. You have to choose the column name, right? Angular braces basically means you have to make a choice. These you don't have a choice. You have to say create, you have to say table, right? If you want to use this, then you have to say if not exist also. So these are all within square brackets, right? So these are options. So we will talk about this when we talk about constraints. But for the moment, if you want to create a table, we will just say create table, name of the table, column name, data type, column name, data type, right? So we know what all data types are there, how to choose the data types also, right? So for the moment, let's say create table is done, right? So we know how to create a table. So after creating a table, if you want to make changes to the table, you will use the alter command, right? Alter table command. So I think let's look at the alter table today, right? And then we can stop. So what all things can you change in a table? Actually, everything can be changed, right? So let's say you have a table called students. This is the name of the table. Then we have the name of the columns, right? These can be changed. If you want to add a new column, right? So that also can be done. Let's say you want to add a column called marks after creating the table, right? So this can be done. If you want to change the data type, that can be done, right? So everything that you see here can be changed, right? So how to do that? So let's see how to add a column to a table that is already existing, right? If I want a new column, then what I will do is I will use the alter command, right? So we will say alter table students, and I want to add a column, right? I'll say add column marks, which is of type integer, right? So this will add a new column called marks. So this is the command, alter is the command. This is called a clause, right? A clause is a part of your command. So the alter table used with the add clause will create a new column for you. It will add a new column in the existing table, right? What if you want to remove a column? Let's say you don't want to have this age column anymore, right? So in this case, you will use the alter table with the drop clause, right? So you will say alter table students, drop column age. This will drop the column called age from the table, right? Next, what can we change? Let's change the name of the column, right? Instead of SID, I want to change it to STDID. So to do that, we will use the change clause, right? So we will say alter table students, change column SID, and this has to be changed to STDID. You should also specify the data type, right? So this will get changed from SID to STDID. Then finally, let us change the data type. Care, I want to change it to where care. So again, I will say alter table students. Now I will use the modify clause. Modify column, student name, and give the new value that you want. You want this to be where care of 30. Just a moment. Okay. Then what else can we change? We can change the name of the table itself, right? So let's say students, I want to change to my students. So to do this, I will use the rename clause. So I can say alter table students, rename to my students, right? So this is one way to rename the table, right? So where you are using the alter table with the rename clause, or you can use the rename command itself, right? So I can say rename table students to my students, right? So what is the difference here? The command used here is the alter table with the rename. Here, the command used is the rename command, right? So whichever way you want to do it, you can use any of these. Let's quickly try this, right? So on our table. So we will take our students table. Let me type and then I'll give you time to do the same, right? So let us say select star from students. Okay, so now let us add a new column. So I'll say alter table students, add column marks, right? So I want integer. So now what will happen? What will happen now? A new column called marks will be added, right? What will be the values inside this?
Null.
Null, right? So whenever we don't know what to put inside, MySQL will automatically put null values into it. If you want, you can specify a default value, right? So you can say default 0. So if you give a default value, instead of putting null, it will put zeros for all the columns, right? So maybe I should have written it here. So default is optional. So I can say here optionally, you can say default, default some number, right? So default any number. Okay, so I'm not going to give any default values. So I'll just say alter table, add column marks, right? So now if I select star from students, you can see null values here, right? A new column has been added and null values are put, right? Now we will take out the age column. So we'll say alter table students, but now we will use the drop clause, drop column age. Now you can see age is gone, right? You have student name and course, no age here, right? Then let's change SID to STDID. So we will say alter table students, change column SID to STDID. Again, I have to specify the data type, right? So you might see slightly different syntax in websites and all. But like I said, we are using the standard syntax, right? So one that will work on all databases. So now if I say select star from students, you can see SID has been changed to STDID. Then what did we want? We wanted to change the data type, right? So let me describe students. So I want to change this char of 20 to varchar, right? So I'll say alter table students, but I will use the modify clause. I'll say modify column student name and just give the new data type that we want. We want it to be varchar. What did I
Change, ma'am.
change and modify both I have given. Right. So now if you describe, right, so char has been changed to varchar. Finally, let's change the name of the table. So if you say show tables, it will say currently there are two tables called students and patients, right? So we'll change the name of students to my students. So we'll say alter table students, rename to my students, right? So now if you see what tables are there in your database, students has been renamed to my students, right? So if you say select star from my students, you will see the same records, right? What is the other way to rename? Instead of using alter table, we can use the rename table command, right? So we can say rename table my students back to students, right? To students. So now if you check what is there in the database, my students has been renamed back to students, right? So this is how you can make changes to a table after you have created it. I'll keep this page open. How can we?
Hello.
Yeah.
Add the column in the middle position, somewhere in the middle.
If you want to add in the middle, let's say you want to add a column called, let's add age back. Depends on where you want to add, right? So let's say if you want to add it between course and marks, here you can say after course, right? So I can say alter table students, add column age integer after course, right? So now if you select star from my, not my students, where is it? So you can see age has been added between course and marks, right?
Right.
If you want it to be the first column, then you have to say first, right? So you can say alter table students, add column, let's say serial number or something, integer, first, right? So this will be the first column, right?
Can we change the position?
Position, it's not possible because actually position is not important. How it is stored is not important, right? So if you want to see something in a specific order, you can select. We will see that when we are doing a select, you can specify whatever order you want. But in the table itself, its position is irrelevant, actually. It makes no difference where the column is. Yeah, did you say something?
Okay, ma'am.
Yeah, right. So would you like to try this? or you can try it at home, and tomorrow if you get any issues, you can let me know. Or if you want us to wait, we can do that.
Similarly, for row, we can change from column to row, no? Syntax.
Column to row,
For the changing row.
changing row in the sense, how exactly do you want to change?
Some values that has been entered.
Uh-huh.
For example, name.
Yeah, you want to change the name, right? Is that what you're saying?
Yes, no.
So see, that is what we call the data. Right? So the name, for example, John or Mary. So they are the actual data that we are talking about. So we have not come to data at all. We are still talking about the table.
Okay.
Remember the example that we took, house and people?
Yeah.
We are talking about the changes that we can make to the house. How to create the house, how to make changes to the house. We haven't come to people at all.
Okay.
To do this, we have to use DML commands. I can use update to make changes to the data here. Right?
Sure.
So that we will see tomorrow. Do you want this notes?
Yes, please.
Yes, ma'am.
Yes, ma'am.
I'll save this and I will share it with you so that you can take a look at it and practice. Let's call it day 2. Desktop.
Ma'am, can you share that theoretical notes also?
The PPT I'm not supposed to share. It is available in the LMS. Tomorrow I will share a book with you, right? And probably a cheat sheet so that you can have a quick look at the commands that we are writing.
Okay.
Download this and let me know. Probably we can wind up for today. Okay. Vrishali says done. Okay, fine then. Let's stop for today. Do practice that alter table. Anyway, tomorrow also we can quickly take a look at it. Right.